Imagine you're hiking near the base of a mountain. Suddenly, the nearby river floods, and your only hope of survival is hiking to an evac team at the mountain's summit. But every upward step is plagued by ever-worsening storms, and you're carrying the weight of all your survival gear on your back. Sounds perilous, right? This is what bacteria face every time we treat an infection with antibiotics. Every drug is another storm the bacteria must weather to survive the mountain and escape with the title of superbug at the summit. Now, we know a lot about how individual bacteria survive these storms. Penicillin rainstorm? No problem. Pull out a raincoat or a mutation that blocks penicillin from entering the cell. But we also know that bacteria, like hikers, rarely climb alone. Most bacteria live in cooperative groups that depend on each other for shared nutrients. Imagine two hikers, one carrying food, the other carrying rope. They share the survival burden, but also the dangers. If the food carrier falls, the rope carrier will starve. So what's the safest climbing strategy? Climb alone and carry everything yourself, or climb together and risk going down with your partner. This is the focus of my research. How does cooperation impact the speed and strategies that bacteria use to survive, resist, and escape the mountain's antibiotic storms? Now, intuitively, the weakest hiker in a group should set how severe of an antibiotic storm the group can tolerate. To test this, I use a model system of 3 bacterial species, grown alone or cooperatively, and race them up a mountain of rising antibiotic levels. I found that highly resistant solo climbers are held back by their weaker partners when they grow cooperatively. I've also seen some cases of shared resistance. Like an umbrella big enough to shield the whole group from a rainstorm, some bacteria break down antibiotics, protecting everyone in the group. Over time, I've also shown that cooperating bacteria evolve less resistance than their solo climbing counterparts. Like a hiker who can't carry a raincoat because they're carrying too much food for the group, cooperation may limit the resistance strategies available to some bacteria. My research suggests that an antibiotic storm targeting a pathogen's weaker partners may be an effective strategy to treat a resistant infection, limit the evolution of resistance, and just maybe prevent any more bacterial hikers from reaching Superbug Summit. Thank you.